Example 2 is slightly more complicated. Again, here I notice that I have a cluster of clearly parallel resistors, because if I take one out, the current will go through the other two, either one of them. However, if I take the entire cluster out, then this one will not get any current. By the same token, if I take this one out, then nothing is going to have any current. That's how I know that my circuit is complex. And like before, I'm going to knock out my parallel first. This is a parallel cluster, so it's a land of reciprocals. Common denominator is obviously 18, so we have 1 plus 2 plus 3 over 18, which is 6 over 18. My equivalent resistor for the parallel, you can even mark it like that, is 18 over 6, which is 3 ohms. So this entire cluster right here that is sitting as a parallel cluster has the total resistance of 3 ohms. Then my total resistance for the entire circuit is going to be 15 ohms. To figure out my current, I go 30 over 15, voltage over resistance equals current, and this is a total current of 2 amps. How is it traveling? In its entirety, right here at this point, it splits, and you can guess most of it will go through 6 because it's the least resistive. A little less will go through 9, and the least will go through 18 because it's the most resistive. And then those 3 currents flow in its entirety through 12. So this is I total here. This will have 2 amps. Then if it takes 2 amps of current, how hard is it to push through 12? It takes 24 volts to push 2 amps through 12 ohms. Remember, you multiply them. V equals I times R. Then, if my total is 30, then I take 30 minus 24, which will have 6 volts. If I took a voltmeter and connected it to these 2 points, it would read 6 volts. So that means that out of 30, 24 is eaten by this hog right here, and everything else gets 6 volts each. Because we pretend that wires are ideal, they have no resistance. 18 takes 6 volts, so that is 1/3 of an amp. 9 takes 6 volts. So that becomes 2/3 of an amp. And then 6 per 6 is 1 amp. So 6 takes 1 amp. And again, voltages don't add up for parallel. They each get 6 volts. So there you go.